All right. Welcome everyone, and let's look at the workshop questions and try to see how we answer the questions. Yeah. So hopefully you were able to have some time to look over the questions. So yeah, I'm sharing it on the screen, and we'll go over it one by one. So the first question, you're given a velocity time graph for a car trip, so that the y-axis is velocity in meters per second, and the x-axis is time. So how many seconds did the car have zero acceleration for? So zero acceleration means that the speed is not changing and the direction is not changing as well. So acceleration is change in velocity over time. If your velocity is not changing, that means that's zero acceleration. So at this point here, we can see that the velocity is always just 60 meters per second between 2 and 4 seconds. So that will be 2 seconds, and that's between the times of 2 and 4 seconds, right? So sketch the corresponding acceleration versus time graph. Be sure to include the labels and axes and title. Yeah, so from question A, we can, and we've also been learning that if you have a velocity time graph, to get the acceleration, you need to figure out the slope of the velocity time graph. So looking here, you have 3 sections in your graph. The first section is this upwards increasing velocity. And you have this second section where you have this constant velocity, and this third section where you have this downwards decreasing velocity. So to get to plot the acceleration versus time graph, you need to get the velocities for each of these sections of the graphs. So so for the first section, for time between 0 and 2 seconds, you need to get the slope of this graph. So take 2 points along the slope. I'll get again the endpoints there. Acceleration is final velocity minus initial velocity divided by final time over minus initial time, or the slope. So final velocity there will be 60 meters per second. Initial velocity is 0 divided by the final time is 2. Initial time is 0. So that will give us a slope of 30 meters per second squared. Okay, don't forget to include the units. For the second segment, we already solved that, answered that in the first question. That's the time between 4 seconds and 6 seconds. The acceleration is 0, right? Because the velocity is constant between, between 2 and 4 seconds. Don't know where that 4 and 6 came from. So between 2 and 4 seconds, the acceleration is 0. And then for the final section of the graph, for the time between 4 and 8 seconds, 4 and 8 seconds, it's a straight line graph. Again, get 2 points along the graph and read the final and initial times and velocity. So again, for simplicity, I'll take the 2 endpoints. My final velocity is 0 at my final time of 8 seconds. So the acceleration is 0 at the final time of 8 seconds. And my initial velocity is 60 at the initial time of 0. So minus the initial velocity of 60 minus the initial time, which is, between 4, that's actually just this portion of the graph here, between 4 and 8 seconds. So that's 60 divided by 4. Negative 60 divided by 4 will give you negative 15 meters per second squared. All right. Does that look okay? Right, so you have now the accelerations for each section of the graph, so you can graph them. So you can put the title acceleration versus time graph. The y-axis is acceleration, include the units meters per second squared. X-axis is time in seconds. So say, for example, I'll choose that's my x-axis, so that this is the 0 point, and that's my y-axis there. And I can do so one grid will be 1 second, so that's 2, 4, 6, 8. I think we're only up to 8 seconds for the time, right? And for our acceleration, our biggest acceleration is 30, and you have a negative 15. So I can divide this as 10, 20, and 30 meters per second squared. So this is negative 10, and that's negative 15. Right, so we've solved here that between 0 and 2 seconds, the acceleration is constant and it's positive 30 meters per second. So between 0 and 2 seconds, the acceleration is 30. Yeah, so that's acceleration equals 30 meters per second squared. And then from 2 to 4 seconds, the acceleration is 0. So from 2 to 4 seconds, acceleration is 0. And then from 4 to 8 seconds, the acceleration is negative 15 meters per second squared. So it's this here. Acceleration negative 15 meters per second squared. Yeah, so that will be how our acceleration versus time graph will look like. It consists of 3 segments of constant accelerations. All right. Any question about that so far? Okay, no questions. Then at what time did the car start to have negative acceleration? So negative acceleration is when your velocity time graph is going downwards, but we can also, so we can see here that this is the time when your velocity starts to decrease. We can also see from our acceleration time graph that you start that you start to have negative acceleration at 4 seconds. Yeah, at 4 seconds. Let me just change this. 4 seconds. And finally, show that the total displacement of the car in 8 seconds is 300 meters. Right, so we have a velocity versus time graph. To find the displacement, we need to figure out the area, calculate the area between the graph and the horizontal axis. So it's just a single trapezoid that we need to calculate the area for. So it's the whole thing, the whole trip from 0 to 8 seconds. Right. So your total displacement will be the area of a trapezoid. That's 1/2 times the height. The height is 60 meters per second times base 1 plus base 2. So base 1, right. So the height is 60 meters per second. Base 1 will be 2 seconds and base 2 will be 8 seconds, the length of that graph here. 1/2 62 plus 8. Okay. So that will give you a displacement of 300 meters. It's positive because the area is above the horizontal axis. Right. And finally, what's the car's average velocity in those 8 seconds? So if we're looking at the graph here, average velocity is displacement over time, right? So we need to know the displacement of the entire trip divided by the time, which we already solved the displacement earlier. So we know from the definition that average velocity or VAV is equal to displacement over time. In the displacement for the entire trip was calculated in the previous question, 300 meters divided by the time of the entire trip, which is 8 seconds. And that should give you 37.5 meters per second for the average velocity. Right. Any question about this question so far? I mean, the solutions or the working? Right. All good. I don't see any questions in the chat box, so maybe we're happy. Okay. Yeah, so we can move on. Right, so we have here a velocity time graph again, but it's a bit more complex. Right, so we want to find, the first question is the average acceleration between 2 and 9 seconds. So 2 and 9 seconds, it's this portion, that's 2 seconds, oh, magic marker. And 9 seconds is this. Right? So we want to find the average acceleration, and we have a velocity time graph. We know that to find the acceleration, we need to find the slope. Okay, but then the slope, it's not a simple single line graph, because you have here an increasing velocity, then constant velocity, and then a decreasing velocity up to 9 seconds. So we cannot get the simple slope of that, but we can connect those 2 points, right? 2 seconds and 9 seconds. We can connect those 2 points, okay, and get the slope of this line. So essentially, acceleration is change in velocity over change in time. Okay. So your final velocity will be the velocity at the final time, that will be 0. Minus the initial velocity, the velocity at the initial time, which is at this point, which is 1 meter per second, divided by the final time is 9 seconds, which the problem actually says, minus the initial time, 2 seconds. Okay. Right. So then, just put it here, your acceleration will be a negative 0.14 meters per second squared, which is actually the slope of this straight line that goes from the final point to the initial point. So the slope of this line is actually negative 1.4 meters per second squared. All right. Any question about that? Yeah, just if anything, just use the definition: final velocity minus initial velocity divided by final time minus initial time. Okay, next question. The car's displacement between 2 seconds and 9 seconds. Okay, so if the slope gives you the acceleration, therefore the area under the graph will give you the displacement. So that means you have to figure out the area under this graph between 2 seconds and 9 seconds. You can divide the total area into actually 2 trapezoids. Yeah, if you divided the area along this line here, then you'll have this trapezoid. Yeah, it's not really a rectangle because you have this slanting line on the right, and then you have the second trapezoid, this trapezoid whose area you need to sort out. Okay, so you have 2 trapezoids whose area you need to solve. So let's say that's trapezoid 1 and that's trapezoid 2. So this displacement over that time interval, 2 seconds to 9 seconds, will be the area of trapezoid 1 plus the area of trapezoid 2. Okay, so the area of trapezoid 1 is 1/2 times the height. The height is the distance between the 2 parallel sides. That will be 2 times the sum of the bases. So this is the first base is 2, 3. So that's 3 seconds plus, okay, you have here 2, 4, 6 and a little bit. So you sort of need to estimate what is this length here, and it's sort of about 6.5-ish. All right. So let's just say that's 6.5. Right. Just up to here, that's 7. So this is no, so sorry, that's 9 seconds. That means one dashed grid is 1 second. So this small bit here is, say, about 0.5 seconds. So that will give you, if you plug everything in your calculator, about 9.5 meters for the area of the first trapezoid. It's above the horizontal axis, so it's positive. The area of the second trapezoid, 1/2 times the height, right? That's the height, the distance between the 2 bases, which is 1, times the sum of the 2 bases. So the first base is this line here, which is about, we've estimated to be about 6.5. And then the length of the second base, which is 2, 4, 6, 7. That will give you an area of roughly 6.75 meters for the area of the second trapezoid. So the displacement will be, the second trapezoid is also above the horizontal axis. So that will be a positive area, positive displacement. So your total displacement between 2 and 9 seconds will be adding these two up. 9.5 plus 6.75, that's 16.25 meters, or roughly 16 meters for the displacement. All right. Are we okay with that? Any question about that solution? Good. Yeah, no question in the chat box. So let's move on. The car's instantaneous acceleration at 8 seconds. So at 8 seconds, it's this point here. That means, yeah, we draw a tangent to that point, which is actually just the straight line graph. And we get the slope of the tangent. We get the slope of that straight line graph over there. Again, I'll consider the two endpoints just because it's easier to read the final and the initial velocities from the endpoints. Okay, so the final velocity is 0. You're going, the graph is going down. And the initial velocity is 3. Final time is 9. And the initial time is, this is the initial time, which is 7. So that's 9. Final time is 9, initial time is 7. Right, so that should give you, so I'll write down here, acceleration should be negative 1.5 meters per second squared. And if you look at the graph is going downwards, and that is consistent with a negative acceleration. All right. And just finally, really quickly now, because I'm aware of the time, the car's displacement when it had 0 acceleration for the second time. So we know 0 acceleration is when the velocity is the same, is constant. This is the first instance when the acceleration is 0. And this is the second instance when the acceleration is 0. So we want to find the displacement by getting the area between the graph between 4 and 7 seconds and the horizontal axis. So it's this area here, which is a rectangle. The area of the rectangle is length times the width. So therefore, the displacement at the time when you had 0 acceleration the second time will be, say, 3 seconds times 3 meters per second. That will give you 9 meters for the displacement. The area is above the horizontal axis, and therefore you have a positive displacement over that time interval. Well, over all the time intervals of the graph, it's above the x-axis, so you'll always have a positive displacement anyway. All right. Okay, so any question about the workshop or the solutions or the lecture for today, or anything else that you want to ask? Right. Okay, just watching the chat box. I don't see any questions, or yes, feel free to unmute yourself or ask a question as well if you have, if you want to do that and you have a question or a comment or suggestion or anything. All right. There seems to be no questions, so right. So I think we can wrap up our workshop and our lesson for today. Yeah, the recordings will again be available on stream once it has finished converting, and I'll upload them right away. Yeah, and yeah, so thank you very much for coming into the lesson. I'll see you on Friday morning for another lesson. We'll now go to still talk about motion, but we'll now look at other ways of finding the displacement, distance, velocity, speed, and acceleration. All right, have a great day, everyone, and keep well and stay safe. I'll see you next time.